Okay, so this is day 9 of our statistics unit, and we are going to continue talking about the normal curve, normal distribution. Everyday people call this a bell curve, and specifically the empirical rule. So just remember that if we go one standard deviation out in both directions, that 68% of the data will be in there. If we go 2 standard deviations in both directions, that will capture 95% of the data. And if we go out 3 standard deviations in both directions, that will include 99.7% of the data. Using those numbers, we can subtract and divide and figure out that each one of these intervals has each one of these percentages of the data. So basically, memorize these numbers that work for a bell curve. Okay, so let's practice. So looking at problem number 1, if you have an approximately normal distribution, that word normal is a signal that it should be a bell curve, and these numbers and percentages should apply, with a mean of 15 and a standard deviation of 23. And then we have some questions, okay? So when you make the curve, we need the mean to be in the middle, and then we'll use the standard deviation to find the other numbers. All right, so since the mean was 15, we put the mean right here in the middle, so there it is. And we got the 38 and the 61 and the 84 by using the standard deviation. The standard deviation is 23, so if we go up by 23 again and again, that will give us the numbers that go on each one of these lines. If we subtract 23 over and over again, we will get the numbers going to the left. Now, what percent of the values are between negative 58 and 84? I'm sorry, negative 54 and 84. So here's negative 54, and here is 84. Okay, so from there to there. Well, that is 1, 2, 3. 1, 2, 3 standard deviations in both directions. And like I said, if we go 3 standard deviations out, that should be 99.7% of the data. Okay, so that is 99.7%. Now, what interval contains 68% of the data? Well, like I just reminded you, 68% of the data is going to be 1 standard deviation in both directions. So from here to here, so using these numbers, that's going to be from negative 8 to 38. Okay, this is 1 standard deviation in both directions. So that will be 68% of the data. We can record that interval using interval notation this way. So negative 8, comma, 38. It looks just like an ordered pair, like an x comma y, but it isn't. It's all about the context. And in this context, this notation means between negative 8 and 38. What percent of the values are greater than 61? Okay, well here's 61. If we want to be greater than 61, we have to look to the right of 61. So that includes these 2 regions, okay? And looking at those numbers, and I really need you to memorize these numbers, that is from here to here, okay? So we're talking about 2.35 plus 0.15. If you add those up, you're going to get 2.5. 2.5%. So this would be 2.5% of the data. Okay, so 2.5% from there to there. All right, so that's it for problem number 1. Now problem number 2. An IQ test has a mean score of 100 and a standard deviation of 10. and then we have some questions. So we need another one of these little graphs, just like this. Look here, I made a little baby one. Isn't it cute? Let's see. So just like I did last time, the mean score is 100, so that's why I put 100 right here in the middle. All right, because that's the mean. Standard deviation was 10, so I went up by 10. 10, 20. Whoa, that should be 130. That ain't cool. All right, 110, 120, 130. Messed up. And then I went down by 10, 90, 80, 70. Okay, so there's that. Now, if the middle 68% of all people are considered to be of average intelligence, what range of scores would represent an average IQ score? Okay, so 68%, as we discussed above, would be one standard deviation in both directions. So that would be from here to here. So in this context, that means an average IQ would be from 90, between 90 and 110. Okay. Now, I might as well scroll down. If a student needs to score 2 standard deviations above the mean on this IQ test to qualify for the gifted program, what would be the minimum IQ score that a student would need to qualify for the gifted program? Okay, so 2 standard deviations above the mean. Okay, so here's the mean, so that's 1 standard deviation, 2 standard deviations. So to be gifted, you'd have to be here or higher, all right? 2 standard deviations is at 120. So anything over 120, so the minimum score would be 120. All right? Notice if they had asked for the interval, you know, that would represent the gifted students, then as an interval, I would have written 120 to infinity. Okay? But they just asked for the minimum value, so that would be 120. Okay, notice the infinity thing though. If we want to talk about the, you know, what IQ scores would be gifted, please understand that this upper interval, this last region, is not bounded. All right, it doesn't have an end. It goes forever to the right. So that's infinity. If we ever have to deal with this one going to the left, that's negative infinity. All right, let's look at the 4 pictures from number 3. Give the percent of the area under the normal curve shown by the shaded region. I'm just going to be using these percentages over and over again. I have them memorized. You should too. So, you know what? I'm going to zoom in. Kabam! What now? Okay, so looking at this one, this region right here is a 34% region. Okay, this region right here is a 13.5% area. So if I add those two up, that's going to give me the percentage of the data under the curve right there. And that is 47.5%.
Good morning, Roswell.
All right, let's slide over to the next one. Okay, well, this region right here is 2.35%. Whoa. .35% of the data, and this region at the end is 0.15% of the data. Of course, it'll be the same thing over here, 2.35% and 0.15%. Anytime you add these two together, 2.35 plus 0.15, you end up with 2.5%. Same thing over here. Okay, so if I add these 2.5% together, I'm going to get a grand total of 5%. So that would be the shaded area in this case, 5%. All right, kabam, kabam. Oh, well, that one, you look at it, you immediately know it is 68%. All right, we've memorized one standard deviation in both directions, always 68%. So, super easy. All right, you have two choices on this one. They're equally easy. Look at it this way. From here over, okay, like this side of the graph, this is 50% of the data, right? It's half the graph. So one thing you could do is start with your 50% and then add your 34, which is what this is, and your 13.5. All right, these are numbers I've memorized off of the chart, as you have hopefully by now. So if you just add those numbers and see what you get, that's going to be your answer. So that is 97.5%. The other way you could have looked at it was this. You'll notice that this shaded stuff is almost the whole graph. It's not quite, but it's almost the whole graph. In fact, it is the whole graph except for this little piece on the end. So if you wanted to, you could take 100% of the curve and then subtract the unshaded part right here. This is 2.5%. That's unshaded. So if I just start with 100 and subtract the 2.5, that's another way of coming up with the 97.5%. All right, what's next? Let's move on. Okay, I guess I have to zoom back out again, see what's going on. All right, a normal distribution has a mean of this, a standard deviation of that, and then we have some questions about it. So we need to draw one of those normal curves. All right, the mean was 25, so I put it right there in the middle. Standard deviation was 5, so I went up by 5 each time, plus 5, plus 5, plus 5, and I subtracted 5 each time going this way, minus 5, and minus 5. So that's where these numbers all came from. All right, moving on. So, find the probability that a randomly selected x value will be in the given interval. So between 25 and 30 would be from here to here. All right, that's one of the numbers that we've memorized to be 34%. Now, when we're dealing with probability, sometimes we express that probability as a percent, like 34%. But it's very often that instead of expressing the probability as a percent, we express it as a decimal, which would be 0.34. So please be prepared to, I would accept either as a teacher, but if you have a multiple choice test, please understand that these probabilities may be given to you as decimals. And you need to recognize, don't be thrown when you see 0.34 and you're looking for 34%. These are the same. You just move that invisible decimal that begins here, move that invisible decimal 2 times to the left, and take away the percent symbol, and that's how you do it. Okay, so here in this lesson, I'm going to write them both ways. Moving on, between 15 and 25. So between 15 and 25 will be from here to here. Okay, now that's not a single number that we've memorized, but we can figure it out because this one is 34% and this region is 13.5%. Okay, so if we add these two numbers together, then we get 47.5%, which is the same thing as 0.475. Okay, between 20 and 35. All right, 20 and 35, here's 20, here is 35. Okay, well, we know that from here to here is 68. All right, we've memorized that. One standard deviation in both directions is 68. And then this zone right here is our 13.5. So if we add those two numbers up, that should give us the percent. So that is 81.5%, or we could say 0.815 instead. Those mean the same thing. Now, at least 20. A lot of kids get confused just with the grammar here. All right, I do not want you to get the wrong answers because of misunderstanding grammar, not even the math. Now, if I say, think about money in my pocket. There's a certain amount of money in my pocket. I don't know exactly how much money is in my pocket, but I can tell you that I have at least $20 in my pocket. At least $20. Is it possible that I have $15 in my pocket? That's the exact amount? No, it's not possible that I have $15. I have at least 20. Is it possible that I have $25 in my pocket? Yes, because at least 20 means 20 or more. Okay, now that might seem obvious to you if you're very comfortable with your grammar. But I know a lot of people are learning English as a second language, and even I've learned that many people who were born speaking English, and English is the only language they know, they still mess this up. So you see the word least, and sometimes that makes you want to think that it means less, but no. At least in Spanish, that's por lo menos, 20. At least means this number or greater. Okay, so you have to understand that to get the question right. So at least 20 means 20 or more. All right, and please understand that we go in this direction forever. So if I want to go ahead and write the interval for that, it's going to look like this. 20 to infinity. All right. Wait, no, that. Okay, yeah, that is the interval, but that's not what they asked us for. We're supposed to say the percent. My bad. So the percent would be, well, look, from here over, okay, can we all agree that that is 50% of the data? Because, you know, this is the middle. This is the median. I mean, the mean. So from here over, that's 50%. So if I just take that 50% and add in an extra 34%, that should be the entire percent. I think that's the quickest way to do it. So that's going to be 84%. Okay, so that's 84%, or of course I could write it as a decimal, 0.84. Now, at least 40, that means 40 or more, okay? 40 to infinity. Okay, so 40 or more. So same deal. Okay, but this time we're just dealing with this teeny tiny interval down here. Again, please understand that this interval is open-ended. We'll go to the right forever. Okay, so we're going to need that infinity. Well, I guess we don't. All right, 40 to infinity. I already wrote that down. I keep doing that. All right, they're asking us for the percent. So we memorized this one. That's your 0.15%. Okay, so that's what that would be. So 0.15%, which is the same thing. Be careful, okay? You notice the way I turn these percents into decimals, where I move the decimal 2 times to the left. Well, this decimal is already to the left of these numbers, so if I move it 2 more times, I'm going to have some zeros in there. So this would be 0.0015 as a decimal. Okay, now, at most 15 means that 15 is the highest number possible. This means 15 or less. Okay, at most 15 means 15 or less. Can't be anything higher than 15. Okay, so we really are talking about the interval that goes from negative infinity up to 15. That's what this grammar is describing. All right, so let me highlight that for you to make it clear. So at most 15, that means negative infinity to 15, like that. All right, so what percentage is that? Well, we've pretty much memorized it by now. We are dealing with these last 2 intervals over here, the 2.35 and the 0.15. If we add those 2 together, we always get 2.5. So you might have accidentally memorized that by now. So the bottom 2 intervals make 2.5%. Okay, so that's what this is. So 2.5%. Which, as a decimal, if I move this twice, I'm going to have to put a 0 in front, would be 0.025. That's what that would be as a decimal. Okay. All right. We're getting towards the end here. All right. A normal distribution has a mean of x bar and a standard deviation of sigma. Okay, those are our usual symbols that we always use. Find the indicated probability. Okay, so greater than or equal to, and I'll focus on the -1 standard deviation part. All right, x bar, that just means we're to the left of, that means we're 1 standard deviation less than the mean. But just focus on this. But greater than, that means we're looking to the right. To the right. So -1 standard deviation is right here, okay? So here we are at -1 standard deviation. Okay? But because it says greater than or equal to, that means we're going to go to the right of that. Okay? So they're asking, what's the probability of being in this interval? To the right of -1 standard deviation. And again, if we start off with this part right here, I think we can all agree that from here over is 50%. Okay? So, now, whoops, I missed. Okay, so this part of the data right here, if I add up all these numbers, I don't have to add. It's half the graph, that's 50%. So all I really need to do is add in my 34%, and that makes 84%. Okay, so that is going to be 84% probability. So that's what these symbols mean. This P stands for probability. So it's saying, what's the probability of picking a random x value to the right of the -1 standard deviation place on the graph? Okay, since we're still talking probability, we will continue to write it also as a decimal. Look at this one. focus on the 3 standard deviation spot, positive 3 standard deviations. Okay, let me start this over. Positive 3 standard deviations are right here. All right, here is positive 3 standard deviations. Now it's just a matter of, are we going to do to the left of this, or will we do to the right of this? Now this says, what's the probability that x is less than or equal to 3 standard deviations over? Okay, so since this is less than, we will look to the left. All right, because of this right here. So to the left, that's going to look like this. So it's everything from here over. Okay, and it goes forever. So this is almost the entire curve. It's everything except for this little teeny tiny piece on the end. So the quickest thing to do would be to start from 100% and subtract your 0.15%. Okay, so I believe that's going to leave 99.85%. All right, that's almost 100, but not quite. Okay, so 99.85%, or as a decimal, that would be 0.9985. Don't round these. Don't round. And this one. Focus on the -3 standard deviations first, because that sort of tells you where to start. Okay, -3 standard deviations is right here. So it'll just be a matter of, will we do to the left or to the right? Okay, this time, once again, we're finding the probability of picking a random x value that is less than or equal to this mark. So that again will be to the left of this mark. Okay, fine and dandy. So if we're talking to the left, we're talking about like this. And of course that is 0.15%. It's right there. So 0.15%, or as a decimal that would be 0.0015. Okay. Do not round that. I think we're down to the last one. This is multiple choice. We're supposed to pick which statement is true. Okay? Now, just before I delve into, the guts of these like words and everything, at a glance, you should be able to judge 2 things. You should be able to tell me which one of these graphs has a higher mean and which one has a higher standard deviation. You should not have to put any numbers in a calculator at all. So first of all, the mean. Let's talk about which one has a higher mean. I'm hoping you can see at a glance that graph A has a higher mean. When we think about the mean, you should be thinking about the balancing point. Okay? If you were going to take this graph and try to balance it on your finger, right? Like this was a physical object in the real world. And I'm just talking about the x's here, not the scale itself. I would have to put the fulcrum, my balancing point, right about here to balance this out, okay? It's about the middle of this grouping. All right? Because there's one extra x over here, I have to move slightly to the left. But anyway, somewhere around here where I put this little triangle, that would be the mean. There, that's my estimate of the mean. Now for this one, these are spread out more evenly, okay? I know that the mean will not be here in the middle because there are extra values over here on the left. So if I were to put my fulcrum, my little balancing point right here, the scale would tip over that way because of the extra weight. So that tells me that as I estimate my mean, I will have to scoot over somewhat to the left. So, probably somewhere in here, somewhere in this area would be my estimate of where the mean would be, where this side of the graph and this side of the graph would begin to balance each other out, somewhere close there. So, we're talking about the mean right now. So it's a matter of which one of these estimated numbers is higher. And you can see that this one is higher. I put some numbers on here just to prove to you that they're the same scale. But if this is 1, 2, 3, 4, then this is, like 4.4 or something like that. This is 1, 2, 3, so this is like 2.5 or something like that. So A has a higher mean than B. So let me write that down. A has higher mean. All right, now let's talk about which one has a higher standard deviation. Now, standard deviation reflects which graph has more variety. At a glance, you should be looking for which graph is more spread out, because that's what variety looks like on a frequency chart like this. So look, graph B has more variety, more variation. Graph B is more spread out. So graph B has a higher standard deviation. B has the higher standard deviation. Okay? Think about it. So I've got your 1s, your 2s, your 3s, your 4s, your 5s, and your 6s. I have that full variety. Over here, I've just got my 6s, my 5s, and my 4s. All right, less variety. So A has a higher mean, B has a higher standard deviation. Basically, as far as this multiple choice, we're looking for the one that says that. A higher mean, B higher standard deviation. A has a higher standard deviation? No. Graph B has a higher standard deviation? Yes. While graph A has a higher mean? Yes. Okay, so option number 2 is the one that reflects the truth. So there it is. That is how you do that, and that is how you think that. I hope this lesson has been helpful to you with our basic statistics that we're covering. And check back with me for the next video. I will see you then.